Okay. Buenas tardes. My name is Fabian Reiser, and together with my colleague, we're going to present our work at the laboratory at the U.T.N Buenos Aires. And we will talk about the exchange from Vienna to Buenos Aires. So, firstly, we'll talk a bit about the theoretical part, about Industry 4.0. Marco will talk about way to measure, GPS. Then we are going to talk about our project, and last but not least about our university in Vienna, the U.T.N. So the Industrial Revolution started with the access to mechanical power, mechanization and steam power. It's called Industry 1.0. Then in 1870, electrical energy came, and with the assembly line, it was possible to produce in big masses, mass production. And 1969, we came to Industry 3.0. Here we had our first computers and electronics components, and machines were automatized, but they were not able to make their own decision. And right now we are at the step to Industry 4.0. This means that machines and humans are connected and can communicate with each other, and yeah, they can make their own decisions. So a smart Industry 4.0 includes a smart factory. And this means that, like I already told, machines and humans are connected. The system can interact with the physical world with some sensors, cameras, and other things, microphones. And yeah, they can make their own small decisions, and are very good to solve unsafe or difficult tasks. And what companies are trying is to make these systems as autonomous as possible. So of course there are some challenges with the smart factories. We have a higher risk of data security issues, because more systems are using data and they have access to data, so it's more likely to get hacked, for example. And yeah, the systems need a high level of reliability and stability, because they are all connected, and if one machine doesn't work, the whole process will break down, and yeah, this leads to huge loss of money and time. And of course we have to talk about the loss of human jobs. There are different meanings. There are some people that are saying that we lose a lot of jobs and we have to change the whole system, and others say we create new, more creative jobs, but I don't have enough time to talk about this, so we go on. Yeah, we have a smart laboratory. So we have two laboratories. One is in Buenos Aires and one is in Vienna, and the user can access to these laboratories from every point in the world. He just has to have his computer with him. He designs his product, and then he sends the CAD file to the laboratory, where it is produced by, for example, a 3D printer. Then we have this robot arm. This robot arm takes the produced part and puts it into the measuring machine to check if it has produced in a correct way, or if we produce 10 times the same part, we would like to know the variance of the production process. And then the robot arm comes again and puts it into the store, and for example, one time each day or two times a week, there comes a person and takes it out of the store and brings it to the postal office and sends it back to the user, or wherever the part is needed. So Marco goes on.
I'm going to talk about the part of the smart laboratory called measuring. because you can only produce something and sell something that you can actually measure. Like you tell, need to know the characteristics of your product, like the color or the weight or the dimensions. And I'm going to talk about the dimensions. And for that, GPS stands for Geometrical Product Specifications and not for the GPS on your mobile phone. And what is that? As I have an example with me. This is some shaft that has, I think we as engineers know, are familiar with it, and we see two dimensions, the length like 100 millimeters and here the diameter of 30 millimeter with tolerances that we know as well as engineers. So we need to measure this. So this is easy. We can measure this easy by hand, but for example, form tolerance is much harder to measure with hand, and we need a possibility to measure this as well. And we need to measure it very fast, because we have a lot of products. So there are two ways to measure things, by hand, as I said, and with machines, with the help of machines. And I'm going to talk about today about coordinate measurement machines. Basically, there are two parts, two possibilities. The one is one that has contact with the product that we want to measure, and the other not. So I'm going to talk about the one that touches the object first. So we have the contact probe here. This is the part, the part of the machine that will touch our object, the orange part, and it can move in three directions, X, Y, and Z, of course. For example, I have a generic object here with two planes, two surfaces that I want to measure. So what do I need to make a... This is the object in the real world that I put in the machines, and I want a picture of it or a file of it in the computer. So what do I need to get a surface into a computer? At first I need the plane, and in mathematics we need 3 points at least to define a plane. For that I have to touch the surface number 1 3 times, and the computer then puts a plane into these 3 points, and so we have a plane, but we don't have the limitations of the plane. How big is the surface? For that we need a line, or 4 lines, but the first line I will take this side. I will touch the surface of the object 2 times for that, because for a line we need 2 points that we connect them. So we have the one limitation of our plane, then the other side, then the third and fourth side. And now we have finished telling the computer with the machine how big our surface number 1 is. And that has to continue for all the other surfaces as well. If we do it for every surface, we have the complete dimensions of the object in the computer file. This is how it looks in real life with a real, more complex object. And this is the machine with the probe that moves around, that can move completely around the object. And I have another example for a circle. We need 3 points to define a circle. So we measure, like here, we would measure 3 times in this hole, we would measure 3 points. And then the computer would make a circle out of it. So 3 points is not very accurate. If you want more accuracy, we measure it more often, and there's another option. We just go completely around the circle and touch it the whole time. And this is the most accurate but expensive version. And the other option, without touching the object, measuring it is with an optical probe, which is used for more complex parts and more fragile parts that we cannot touch the whole time. but it's way more expensive and not used that often, only if it's necessary. So now we come to the machine that we have in the laboratory Máquina in the U.T.N campus. Fabian and I work on this machine, make our projects on this machine, so I will give you a quick introduction. This is a coordinate measurement machine, like I described before. It's about 2 times 3 meters big and 3 meters high. And here is the position of where the probe will be situated. And for example, this is an object that we can measure, and we have to move around, so we can measure this object with the probe. So how can the machine move? It has 3 axes. This is one axis, for example, X. This would be the Y-axis, and this is Z-axis, which can move up and down. And how to move in these 3 directions? At the moment, we have to use our hands and turn these wheels to make it move. And if we are on a position, the machine can tell us the coordinates of this position here, but it's only a display. It doesn't save the coordinates at the moment, and you have to write it down and calculate the dimensions of the object yourself. This is how it is at the moment. Now we come to my project. My project is to install electric motors to make the machine move without the use of hands. So you can just press buttons and the machine moves where you want it to. This includes 2 parts, the mechanical part with motors and other necessary things, and the electronic part with the electronic components. And if I have time left, also I will try to make something that I can control the movements with the PC, but we will see. Now we come to Fabian's project.
Okay, I would like to present my project. It's also on the same machine, and it's about the measurement, so the data of the machine. So what you want to do is to measure in 3 dimensions. Therefore, I need 3 sensors. So my tasks are that firstly I have to develop a linear guidance for the sensors. Then I have to choose the sensors. It's a measurement machine, so I need a very high resolution, of course. Then I have to create an interface between the analog signal coming from the sensor to the computer. And to evaluate and visualize the data, I am going to write a Python code. So, yeah, the goal, summarized, is the visualization, the digital evaluation on the computer with this Python code. So I choose a linear incremental position sensor. It's a very small chip that can recognize a magnetic field coming from this magnetic band. So it knows exactly where the band is, and it has a high resolution. We can measure 0.5 micrometers with this. This is how it looks finally. And to put the data into the computer, we are going to use Arduino as the interface. So, small summary about our project. So, my part is the digitalization of the measurement data, and Marco does the manual electrical drive. So, for interested students, we have a lot of future projects. For example, to control the motors to the computer. To create better probes, we have a lot of ideas for other probes which already exist, so you can create new ones. Then it would be, so we have the same machine in Vienna, but a newer one, which can be controlled from other laboratories and which can be controlled with the computer, and it would be nice to control this one in Buenos Aires as well, so we can control it when we'll be back in Vienna. And yeah, of course, for the smart laboratory, ideas never end, and there's a lot to do. If you're interested, please contact us. And in the end, I want to say some words about our nice university in Vienna. It's our old university, it's in Europe, so it's 2 years ago we celebrated the 200-year anniversary. And yeah, we have a lot of famous alumni, but the most famous, I don't know if physicists will know it, the Doppler effect, is Christian Doppler. There are some others, and we even have an astronaut from our university, which I personally met 2 years ago. And yeah, we have a lot of life and culture in Vienna at our university. So we have these two interesting teams. One is the racing team, where students can decide to build a racing car and take part in international Formula student competition with a lot of other university. And we have the space team. I'm a member of the space team, and for me it's really interesting because yeah, I love aerospace engineering. At this moment we are trying to build a rocket that is going 42 kilometers, at least 42 kilometers into the orbit, and it will reach 3 times the speed of sound. 2 months ago we shot a small satellite into the orbit, and yeah, that is so. If someone would like to go to study there for a semester, it would be interesting to see what happens there. And of course in Vienna we have a bar where you can dance waltzer, and we have a lot of cultural stuff there. So yeah, in Vienna the mobility is very important for our university. We have 33 partners worldwide, but just one in South America. So this one should be in Buenos Aires. Yeah, it's just in Buenos Aires. And yeah, for PhD would be interesting. We have a lot of research fields, which you can see here, and a lot of other stuff to do. So thank you very much. Muchas gracias.
Excellent.
It's boring.